Good afternoon, everyone. Hope you all had a good lunch. I know I certainly did. If you want to just zone out for the next hour, I totally understand. But I'm really glad to be here. This is my first time at KanDDDinsky. I guess the last time as well, because it's going to change name. First time in Berlin as well, and it's a fantastic place. I'm really enjoying it. So thank you for having me, and thank you for choosing to spend the next 50 minutes with me. So for those of you who don't know me, my name's Adam. I'm originally from the UK. I live in Switzerland now, in a place which looks a little bit like that, actually, minus the fence. We like to sit on fences in Switzerland, but we don't like to build them. I work for a company called Particular Software. We're the makers of a product called Service Bus, which you may have heard of. Has anyone heard of Service Bus? Okay, that's about half of you. Great. So I'm not going to talk about that today. But I will mention that Particular Software, our mission as a company is to make organizations better at delivering and building complex software systems. Now, in doing that, we talk to a lot of people. So we come to a lot of conferences, we go to a lot of meetup groups, we have a lot of customers who raise support cases, and we have really interesting conversations with them about problems they're having with complex software systems. It's very often around shuffling data around, versioning components, rolling out things together, dealing with problems of data coupling. Now, it's so often in these conversations that we realize quite early on sometimes, if the service boundaries were a bit different, if the system was sliced up in a different way, we may not even be having this conversation. So the problem you've come to us with may not even exist. So I think it's a really important thing to talk about, because if you can think about a kind of tree of problems, where one problem causes other problems, getting the service boundaries wrong is one of those things. It's somewhere at the root. And if you get them right, you can avoid a whole class of problems altogether. So I think it's a really important thing to talk about. In doing so, I'm going to intentionally take some of the things you may have heard about in software literature and things you may have taught and things you've seen in the industry and kind of tear them upside down, tear them apart and kind of completely switch them around. So that is intentional. That's something I like to do. I do expect that to raise questions. So we may not have time for a Q&A during the session, but I'm around for the rest of the afternoon. So please don't hesitate and challenge me on this, to challenge me on this stuff. So I'm going to start off by looking at a system, right? So this can be any kind of system. It doesn't really matter what it is, right? These might be classes, they might be functions, they might be methods. It's not too important. But we do tend to split our systems up in these kinds of ways these days, right? We don't really write program main and put everything in there, or I really hope you don't do that. I used to do that in the 80s when I taught myself BASIC. Things have moved on a bit since then. We do tend to structure our things into objects or functions or methods or procedures or something. That looks quite nice, right? It kind of looks quite nice and organized and neat. You can kind of see there's an area of responsibility up here somewhere, and there's another area of responsibility down here. And you can see how this diagram might be useful. You can kind of trace the flow of information through the system. That's all well and good, but we deal with these people called users or business people, and they tend to have ideas. And you may be sitting in by your desk with this on your wall, admiring it, and then someone from the business team kind of bursts in and says, I was out playing golf with my buddies at the weekend. We've got this great new idea. We're going to make a ton of money, right, with this new feature. And you kind of scratch your head and you think, well, I think we can do this. Yeah, I think I can see what you're saying. But what we need is some class up here is going to need information from some class down here. Now you think, well, it kind of doesn't really fit with the diagram too well. If we were to make that call, it's like, it looks a little bit ugly compared to the rest of the lines on the diagram, but after all, our architectural constraints, our object-oriented design, is not stopping us from doing this. And each of these objects may have nice intention-revealing names and methods and all the rest of it. They're encapsulating something, and this is what they're designed for. If this object up here uses the public interface of this object here, what harm can that cause? So you think, okay, well, rather than trying to shift things all around, let's just make the call and see how it works out. So you roll it out into production. A week later, the feature's working, you are making more money, and the business is really happy. You're the superstar, and you're done, right? So the feature's out. Sooner or later, the business will come along again and they'll say, I don't know, I was out snowboarding last weekend, I had a great new idea for this new feature. And you realize you're in the same kind of situation again. You think, well, we need some data up here for some class down here. The last time we did that, actually kind of worked out pretty well, right? Didn't cause any bugs, the feature works. So why don't we just do the same thing again? Why don't you just try that on for size again and see how it works? So you take the plunge, you make the call, and you roll it out. Sooner or later, you find yourself doing something similar again. Now, you can see where I'm going with this now. Given enough time, and it may be 3 months, it may be 6 months, it may be a year and a half, no one sets out to make a mess. But given enough time, you may end up with something which looks a bit more like this. Right? There are kind of lines going in every direction. This diagram starts to lose its usefulness, because you speak to your colleague and you say, well, that feature we rolled out last week, did you use the diagram? And I say, well, no, I haven't looked at that thing in weeks. I haven't looked at it in months. It's useless, right? It's just a plate of spaghetti. So what that means is we can kind of take the lines away and just have a bunch of boxes, right? And now, each of these in isolation might look sensible. So you've got these classes or whatever, and each one in its own, encapsulates something that's got a nice name. But the problem is it becomes really difficult to make changes to the system and to know where to make changes to the system. You want to introduce a new feature, you just got to kind of dive in and try it. Because you don't really know what's calling what, you don't really know what you're going to break by making those changes, and you end up in this kind of code safari, kind of going down the rabbit hole and finding out what you can do and what you can't do and what you might break. So it's not that useful to have these individual boxes anymore either. Right? You may as well just have one big box, because you can't really use those boxes and say, well, that's where we need to make the change. You just have to kind of go exploring. And at this point, this is what some people refer to as a big ball of mud. Right? Has anyone, and it feels a bit like this guy looks to work for this kind of thing. Has anyone seen this architectural pattern in their career? That's pretty much everyone. That's what I expected to hear. I guess in my career, I've probably seen this more than any other architectural style. Right? It's a sad truth, but there it is. So we know that we can do better than this. So we read about service-oriented architecture, we read about microservices, a bit more on those a bit later. But we know that we can split these up into some kind of services or components, right? And what we have between them are thin lines of communication. We want loose coupling between these services. That's all well and good, right? So that kind of looks quite nice so far. But the problem is, these business people come up with new ideas, and they might say, well, I was out, I don't know, biking the weekend, I had this great new idea, I think we can make a ton of money. And you look at it and you think, well, yeah, but we need some information that's in this service over in this service over here. It might be something really innocuous, like the price of a product. So 100 euros. Right? It's just a number. How much harm can that do going across the wire? So you change the service interface, you add this new number to it, and you make that change and you roll it out. Right? It's still loosely coupled, just an extra number going across the wire. It works, you're making more money, and everyone's happy. Sooner or later, the business coming along again said, I was out jogging at the weekend, another great new idea, and you realize you need to do the same kind of thing again. Again, it might be something innocuous like number of widgets in stock. We've got 42 widgets in stock, just an integer number, right? Still, loose coupling should work. I guess you know where I'm going with this as well, right? No one sets out to make a mess. No one sets out to build a plate of spaghetti. But given enough time, and that's the important factor here, think months, think years, 2 years, you may end up slowly with a system which starts to look a bit more like this. This looks similar to what we've already seen. We've already seen we can take the lines away, right? We can take the boxes away, and we're back to the big ball of mud. This time it's a big ball of mud with a difference, because you've rolled it out to 4 machines, right? So it's a kind of distributed ball of mud, if you like. They talk to each other over the network, right? Which is it's more expensive than class-to-class in-memory calls. You have to roll out 2, 3, or maybe even all 4 of them at the same time, because they're so tightly coupled. You make a change in one, you've got to change the others. So you've actually ended up in a worse situation you started with. You may as well just have stuck with the one big ball of mud on one machine to start with. So you've reached out for SOA or microservices, you've ended up in a worse state. And that's a shame. So how can we avoid that? So let's actually get into an actual use case here. Let's get into a real use case. I'm going to use Amazon because it's a great example. Amazon is a highly service-oriented company. So there's not a kind of 1 terabyte Amazon.exe, which you roll out. There's kind of like a bunch of different components grouped into logical services. There's that famous email that Jeff Bezos sent out. Everyone does service-oriented architecture, or we all build services, or you get fired. He actually sent out that email. That actually happened. So, highly service-oriented company, and we're all quite familiar with it. I'm sure you've bought something on Amazon or something similar. Now, once you've filled up your shopping basket and you're ready to buy, what you do is you actually start a workflow, right? So you go up to this button, proceed to checkout, and then you start a workflow at that point. The next step in the workflow is to enter your address, enter your credit card details, I don't know, shipping options, so forth and so forth. And then when you're happy, you're good to go, you click Buy Now. And that's the end of the workflow, right? Start of the workflow to the end of the workflow. As I said, Amazon is highly service-oriented. This is a very slightly simplified version of the back end. I'm going to assume they have kind of sales, finance, and shipping. This is just an example. When we finish that workflow, we send a message to sales to say, place the order, right? I want this stuff. Charge me for it and ship me it. Sales does sales stuff, right? It looks at, have we got this product in inventory? If not, can we order more? Are we allowed to sell to this country? Whatever sales needs to do. It then says, right, that's all fine, good to go. It then publishes a message. Right, it publishes a message called order placed, which might be received by finance and shipping. Finance does the stuff that it needs to do. It says, well, I need to charge the credit card or whatever, and it charges the credit card, yes, successful, the order's been billed for, right? Publishes another message. Shipping says, okay, right, an order's been placed here. Okay, right, it's been billed. I'm going to do my shipping kind of stuff. I'm actually going to call a courier or call the post office and actually send this to the customer. So it does all its stuff. It might raise another event, which is order shipped, and something else might then react to that and so forth, like send an email or whatever it needs to do. Question now is, what should each of these events contain? So, should order placed contain all the information that finance needs in order to bill for the order, right? So should it contain all the credit card details so that finance can then do that work? And should order placed contain all the information that shipping needs to get that thing to the customer, so their address? That would work, right? There's no reason that wouldn't work. But what's the problem with that? We're back to this coupling. Right? Because all of a sudden, sales needs to know all kinds of financy stuff, like credit card details, and it needs to know all kinds of shipping-y stuff, like addresses, and it has to put all that information onto this big event here, this order placed, address, credit card details, all the rest of it. That's coupling. You want to change something, you've got to change it in sales and finance, or sales and shipping. What if you want to start charging in Bitcoin? You no longer put credit card details on that event. You put, I don't know, what is it, a Bitcoin wallet ID? I'm not a Bitcoin expert, but something different, right? What if you want to sell ebooks? You don't ship an ebook to an address. I mean, you could on a USB stick or something. That'd just be weird, right? You send an email or you give them a link or something. So all of a sudden, that order placed event has lots of reasons to change, and sales needs to know about a lot of different things like ebooks, physical books, Bitcoin, credit cards, and the event itself either has to have a Bitcoin wallet ID or it has to have credit card details. If it hasn't got an address, it must have an email address because it must be an ebook. And it's kind of this nullability soup, like all this kind of weird nullability rules around the event. Now, that ultimately becomes a very fat event, right? A whole bunch of data on that event. What we want to do is we want to slim that event down to a thin event. What if we could slim it down to the point where it only contained an ID? So sales would say the order's been placed and the ID is 123, order 123. Finance then says, right, order 123, right, I'm going to bill for that. Raises another event, stay with me on this, it sounds a bit weird so far, but stay with me. Raises another event, order billed, the order is 123. Shipping receives that and just says, yeah, the order's been shipped, and the order is 123. The problem is, how should they know how to ship them, and how should they know how to charge for them if we've only got an ID? First assumption, when we place an order, the implicit assumption there is that we create an order ID when we create, say, an order in the database in sales. So we get this command in, sales says, right, let's see if we can make this order or not. Yes, we can, writes a row into the database as an order ID, and that has an order ID on it, right? So we're creating that order ID at that point. Now remember, that is the end of the workflow, right? That's creating the ID at the end of the workflow. What if we turn that upside down and turn it around and say, let's create the ID at the beginning of the workflow? What if we create the ID here, right? Remember, proceed to checkout is the beginning of the workflow. We can create the ID at that point. What we can then do, in the next step of the workflow, when we enter our address, we can send a message to shipping to say, this is the address for order 123. We can then send a message to finance to say, these are the credit card details for order 123. Then when we get to the end of the workflow, we then send a message to sales when we click buy now to say, I want to buy this stuff, and I don't want to buy these products. So if we look at that at the back end, we send our address to shipping, we send our address to credit card details to finance, we then send the shopping basket to sales. Sales looks at the products, right? It's only received a message with the products, and it says, it looks at salesy kind of stuff, like can we fulfill this order? Raises that event with just an order ID on it. We've already told finance what the credit card details are here. So finance knows how to go and charge. Finance says, yep, the order's been billed, order 123. We've already told shipping our address details up here, so it knows how to ship. So now we do only have IDs going across the wire between the services. Now if you want to introduce Bitcoin payment, you just have to make a bunch of changes in finance. You want to ship ebooks, you just make a bunch of changes in shipping. You don't have to change those events. There's no reason to change that single event with just an ID. Now the thing is that if you look back at the UI, that's all very easy until you think about, well, how is finance going to get the Bitcoin wallet ID instead of the credit card details? Surely this UI here is introducing the coupling back again, because this UI is going to have to know about all the different services. It's going to have to know that here it needs a kind of radio button type thing for credit card details or a Bitcoin wallet ID. What if finance owns that part of the UI? So you don't have a monolithic UI, you actually have services owning different parts of the UI. Now, I'd like to go into this in a lot more detail now, but that would add about 30 minutes onto this talk. So what I will do is I'll refer you to another talk by a colleague of mine by the name of Mara Servienti. I will distribute the slides after the session, all right? So you don't have to kind of remember this title or anything. But he goes into a lot of techniques for doing that in a lot of detail about how to actually produce that composite UI. So that all sounds great, right? I hope that makes sense and you can see how that might work. But why is it then that we ended up back in the big ball of mud? Why did we end up with this distributed ball of mud in the previous example? Well, it all started here. So that little red arrow at the top, that's the bit that pushed that ball of mud off the hill and started rolling and started growing. It's that little innocuous piece of data sharing that started us on this bad path. So I think it's a good idea at this point to describe what a service is and what a service is not. So first of all, what a service is not. This is the easy bit. Something that just does kind of like calculation or validation or something like that, that's not a service. That is just a function, right? That is what a function is. Something that does CRUD on entities is not a service. And really importantly, just because you put a web API, HTTP or SOAP or something on top of a database doesn't suddenly make it a service, right? Contrary to a lot of the things that have been written in the past. It's not kind of like service magic dust. It's still a database. You've just changed the entry point from a connection string to a URL. Rather, a service is the technical authority for a specific business capability. Now, you can kind of make a sort of comparison to OO here, like object-oriented programming. If you've ever read anything by Alan Kay and people who wrote about object-oriented programming in the past, they never wrote about polymorphism and inheritance and that kind of stuff. It was about encapsulation. So an object essentially was something that encapsulated logic and data, received messages in, performed operations, and sent other messages out. So that gives us a level of encapsulation, but the objects kind of aren't really big enough, because if you've done anything with an object-oriented program, you know that you need methods with arguments and properties on objects, and you have to do some kind of level of data sharing. So then you can step up to maybe components, and you might think .NET assemblies, or Java jar files, or NuGet packages, or something like that. They are a stronger level of encapsulation, but they're still not quite big enough. You tend to have a public API on those things with methods and arguments. If we then step up to the service level, there's a fundamental difference. See, classes and components are physical concerns, right? Those are physical things that we build. Services are logical concerns, right? They're not physical things, they're logical things. And because we decouple ourselves from the physical and the logical, it allows us to have a much stronger level of encapsulation, right? That's ultimately what it's about. It's about encapsulation. Really importantly, all business rules and data reside within some kind of service, right? If you've read stuff by Eric Evans about bounded context, it's kind of like a bounded context. The definition of that is slightly looser. So you can use bounded context just for, say, as a conversational tool even, just to standardize on a ubiquitous language. But the definition of a service is a bit crisper. It's a bit more highly defined. And everything is in some kind of service. Not that you don't have kind of service A, service B, service C, and then other stuff. Because the really interesting questions are in that other stuff. If you avoid answering those questions, then you avoid finding out what the real problems are. And this kind of makes sense because the code that we write has a business purpose. You know, it should have a business purpose, unless you've realized that your project's going to fail and you just teach yourself Rust or something on the side. You know, then I understand you doing that. But otherwise, you should be writing code for a business purpose. And if the service is a technical authority for a business capability, it follows that all code must be in a service. I hope that makes sense. The relationship with systems is slightly different. So you may have seen systems like that. Have you ever heard the term back-end service? I've heard that a few times in my career. It's very tempting to draw service boundaries along these kind of system lines. But the thing is, these are physical concerns. Okay? Systems are physical concerns. Services cut across those because they're logical. Now, the implication of this is that you may have a service which ships something to a mobile app, something to a .NET backend, and something to some other Java thing. So, different technologies within a service. It also implies that a given system, like a mobile app, will have components and many services, right? So it's a many-to-many relationship. It's like, if you ever played with Lego, and you have that kind of green board, imagine that green board as the place where you're going to build your system. You have a pile of bricks here, like big bricks, medium bricks, small bricks, and you take bricks from each pile and you build a house. That's what it's like to build a system from services. Services are logical, design time concerns with business-aligned boundaries. Systems are physical runtime concerns with technically aligned boundaries. And if there's just one thing I'd like you to take from this talk, it is this. It is this physical and logical decoupling. Because I said earlier that service boundaries are kind of at the root of the problem. This is even maybe one step lower. If you can decouple the physical from the logical, it will allow you to find the right service boundaries. If you don't decouple that, it will prevent you from finding them. So this is really, really important. Physical is not logical. So let's have a look at an actual example to see what it's actually like to try and find some business, some service boundaries. So very simple example, the business might tell you, well, we've got customers, we sell them products. So what we like to do first of all is we go to our whiteboard and we draw a box for customers and we draw a box for products. And then they tell us that a customer has a first name and a last name and a status, and a product has a name, description, and price. And then we start writing classes to represent these things. It seems like the natural thing to do. You know, these are our entities. But the thing is, if you start to look within these boxes and you start to look at the actual pieces of data, some interesting things can emerge. Now, the thing about businesses is they're a strange bunch because they very often don't know what they want, but they almost always know what they do not want. And you can take advantage of that. So you can ask some really dumb questions. I like to use a technique called anti-requirements, where you ask a dumb question like, if the customer's first name begins with an S, does that affect their status? And the business will look at you in a funny way and say, you have no idea about this domain at all, do you? Not only would we never do something so dumb, no one in this industry would do something so dumb. Now, when you hear that, you've struck gold, right? Because what have they just told you? They've told you a stable business rule. They've told you there's no relationship with a customer's first name and their status, or their last name and their status. So why don't we put them in two different places? And this is what you're trying to do. At this stage of modeling, you're trying to get all the different things, all of these little pieces of data, and you're trying to put them in piles. You're just trying to put them in piles of related stuff. These are not classes. These are not database tables. These are just piles of related data that somehow affect each other. You can look at this now and say customer status, right? It's all on its own there. What is customer status? What do you use it for? And they say, oh yeah, we use that to work out the price, to charge them. So, if they're a gold customer, they get 20% off, silver customer, 10% off, and so forth. Think, okay, right, customer status and price have got something to do with each other then, so I'm going to put them in the same box, right? Piles of related stuff. Then you look at what's left. You've got the product name and description kind of go together, because if it's a luxury product, a luxury X, the description tells you why it's so good and why you need to buy it. So you kind of put them in another box down here. And this is a simple example. You can imagine that in a more complicated example, you're going to end up with a very, very different model emerging down here to what you originally had. And this is what modeling is about. This is what service modeling is about. It's about use cases, behaviors, right? It's about the field, not the entity. Who here has read Eric Evans' DDD? That's probably most of you. So if you were like me, you read about entities and aggregate roots, value objects, you got really excited, you ran to work and started writing them. And a lot of people did that. And Eric at one point said that he wished he'd put that in the second half of the book. And then he later said he wished he just put it in the appendix. And later he said he just wished he left it out altogether, because it distracted us from the more important stuff in the second half of the book. I'll go ahead and say it, right? Entities are bad. Okay? Modeling is not about entities. It is about use cases, scenarios, and behaviors, right? It is a bottom-up exercise, not a top-down exercise. And it's tough because our brains are kind of wired to the stuff on the top, right? We like tangible things. When someone says we've got a customer, we like to draw a box on the whiteboard for a customer, and we like to create a class called customer. But look out for that has a. Right? When someone says customer has a first name, that bit in the middle, has a, is a sign you're going down an entity first, a noun-based modeling approach. That's something to watch out for. I would also recommend not naming these things too early, right? Call them colors, call them names of planets, animals. A team that I was in, we used kaiju monsters, so like Godzilla, Godzuki, and other more bizarre ones like Mothra and Udaku. We just left those names there, right? We just left those names there. The thing about, if you name these things too early, it can cause one of two problems. You may have a piece of data and you may say, well, the use cases are telling us it belongs in billing, but that can't be billing, right? That cannot be billing. So you kind of try and find another place for it. And the converse problem, you've got a piece of data and you say, oh yeah, that's inventory. So you're putting it in inventory because it's called inventory, rather than looking at the use case. And now that could actually drive you more back down to kind of entity type approach. So avoid naming these things too early. We just left them named kaiju monsters forever. We didn't even bother trying to give them proper names, because it wouldn't have really added very much. It was the use cases which were more important. So we're going to look at another example. Insurance. Does anyone here work in insurance? A few lucky people. Okay, so if I get all this wrong, then You can tell me if I get this wrong, right? But insurance is an interesting business because it kind of tends to be based around a kind of front office and back office model, a bit like banks, where I've spent a lot of my career. The front office is all about selling policies, right? So you might have kind of policy service thing here, and ultimately it's about fear, right? It's about making you afraid enough about bad things happening that you're going to buy insurance. Right. And actually, I gave this talk in Russia once, and they told me that the word for insurance in Russian actually has the word fear in it. So there is some level of truth to this. The back office is all about dealing with claims, right? So they get claims in, and actually their job is to work out how little they can get away with paying. So might sound a bit cutthroat, but that's the model of any business, right? It's maximum money in, minimum money out. Have I got that more or less right, insurance people? Kind of. So the thing is, a colleague of mine was called in to actually look at an insurance company's service boundaries to check whether they're right. Have we got the right service boundaries? And they actually showed him this. They showed him a policy service and a claims service. Now, I don't know anything about insurance companies. I know what it is to buy insurance, but I don't know how to run an insurance company. But I can say with a high degree of confidence that that is wrong. The reason it's wrong is think about a typical use case. The dog chews up my sofa. All right, I send a claim. What's the first thing that the claim service does? They look at the policy. Right? They look at the small print and say, right, can we get away without paying this? That's the first question they ask. So there's going to be a whole load of those red lines going between these two services. The policy service could publish that information to claims when the policy is sold, or claims can get it on demand. It doesn't matter. It doesn't matter when it happens. But data is going to go across the wire between these two services. A lot of very complex data. You want to change one thing, you've got to change both, right? They're highly coupled. So it's all well and good kind of saying, well, it's wrong, but you've got to then suggest maybe what is right, and especially as a consultant, this can be quite stressful because finding service boundaries is a labor-intensive exercise, and it takes a lot of time. And a lot of time you can kind of feel for days like you're kind of bumbling around in the dark and bumping into things and not really getting anywhere. And 4 days after you've been there, the business say, well, you've been here 4 days now. On Monday you told us everything was wrong. It's Thursday. Have you found the right stuff yet? And you kind of, I'm getting there. That meeting you set up yesterday was really good. Just give them some answer to make them happy. But what tends to happen is that you'll get a flash of insight sooner or later. You might realize that in all the use cases you've been talking about, I never really hear travel insurance talked about at the same time as home insurance, and if I crash my car, I don't show them my sofa, that doesn't kind of really work. You can almost like use a form of anti-requirements there to try and find those things out. So you think, right, I think I might be onto something here, and you draw 3 new boxes, one for home insurance, one for travel insurance, one for car insurance. You then call everyone into the biggest meeting room you can find in the building on a Friday afternoon, and you stand at the front and you tell them your huge revelation. Right? I've had this enormous insight. Home insurance is different to travel insurance. Travel insurance is different to car insurance. And then the business look at you and they say, how much have we just paid you to come in and tell us something that we've known our entire careers and the industry has known for the last 50 to 100 years? Now, again, you've struck gold, right? Because your use cases are telling you this. The business are telling you that's obvious. That's a really good sign that you've found some good boundaries. Now, the thing is that you might say, well, why didn't we just ask them in the first place? Now, why did I spend that week, talking through all those use cases and drinking all that coffee and getting really stressed? Why don't I just say to them, how's your business organized? That's obvious. That is also obvious. It depends who you talk to in the business, right? If you look at it from a top-down way, there are a multitude of ways of splitting this thing up and talking about it. You might get lucky. They might tell you, oh yeah, we've got home insurance and travel insurance and car insurance. Or they might tell you, yeah, we've got policies and claims. Or they might say, yeah, we've got products and customers, right? It is not a top-down exercise. If you go top-down, starting with entities, we've already seen where that can lead us. It is a bottom-up exercise where you look at the data, you look at the use cases, and then the model emerges, right? It's a bottom-up, not a top-down exercise. People often say to me, do I really, really need to go to all that detail? Do I really need to look at those use cases and behaviors? And the answer is yes. It is an intensive exercise. It is an expensive approach with huge benefits, but you need to be able to invest that time. Now, this kind of front office and back office split up here, it's just one example of an organizational boundary. Now, it would be nice if you could go into a company and say, right, so you've got a sales department, a marketing department, and a finance department, right? Those are the service boundaries, off you go. That would be really nice. The problem is that I think that may have worked at one time, right? So if you think back, let's rewind back to before computing, right? Before we kind of automated everything with computing. Data access, so data used to exist on paper, and paper used to exist in filing cabinets. Data access in those days was very expensive, right? If you needed data from a filing cabinet on one side of the building, then you needed data from a filing cabinet on the other side of the building. That was a very expensive exercise. So you tended to organize yourself with your data. You'd have the filing cabinets that you needed kind of near you somewhere. And then to perform a job, you get a piece of paper, fill something out, put something in your outbox. Someone might come along and then take that and put it in someone else's inbox. They'll go to their data that's around them. They'll put something in their outbox, and that'll come back via a kind of trolley person back to your inbox and so forth. So companies were almost forced to be service-oriented because of the cost of data access. Then we came along with our fancy databases and our fancy computers, and we put one on everyone's desk. And all of a sudden, everyone could access any data anywhere. It's just a case of having the right security flag, which is often just knowing the right person. So what's happened is managers in modern companies have taken advantage of that. And the modern department has almost become a kind of fiefdom or mini kingdom, right? Managers like to empire build. They like to build boxes under them in the org chart. I've seen managers leave, and then the other managers kind of fight over the scraps of the department, right? Grabbing bits for themselves. Because the more boxes you have under the org chart, the more bonus you get, and the more likely you are to get promoted. So the organizational boundary has become something else. It's not a very good indicator of business capability. You might just end up modeling a manager's skill in empire building. These things change very often. I used to work for a very big company in Switzerland where my organizational unit changed 8 times in 1 year. I don't want to be ripping up my boundaries and changing them 8 times per year. So beware the organizational boundary. It's often not a very good tool for us. And it's a real shame. It will be a lovely shortcut, but it doesn't tend to work. So I did promise to talk a bit about microservices. Now, microservices are interesting, and I think a lot of really good stuff has come out of the microservices literature. A lot of stuff about independently deployable components and all of their various ways of doing that. I think that's really good. I do have one big concern, right, and I'll try and illustrate that to you. So microservices are a weapon in our battle against the big wall of mud. It's another thing that we can reach for to try and avoid this. So we read about microservices and we say, okay, well, let's split this thing up. Let's split this thing up into some microservices, and this is already looking better. We can look at these things in isolation. Then you read some more literature, or someone comes along and says, well, 5's not really enough. You need to have a few more than that to be really doing microservices. So you split it up a bit more, and you end up with 13 microservices. And at this point, you read some more literature like you must optimize for deletion, right? So you must be able to delete one microservice and rebuild it in a week. Otherwise, it's too big. So you think, okay, these things are a bit too big still. So you split it up even more. Okay, we must be doing microservices now, right? And then you read, it's got to be on Docker. So yeah, okay, whatever. We must be doing microservices. Now, it looks quite nice. But the business have this habit of coming along and saying, I was out, parachute jumping last weekend, and this great new idea. And you realize you need some data up here and a microservice down here.
our architectural constraints, our microservices, the way they're described to say that, well, each one is nicely isolated and encapsulated, it has a public interface, respect that, and this is what they're designed for. It's designed, one microservice is designed for consumption by another. So you make the call, you roll it out into production, and it's all fine, it works. Sooner or later, they're doing some other weird activity and there's some other new great idea, and you find yourself doing the same thing again, right? And you know where I'm going with this. Given enough time, right? 6 months, a year, 18 months, 2 years, more, it doesn't matter, but given enough time, you may end up with something looking like this. And we've seen this before, right? We've seen that the lines are kind of useless, we may as well take them away, we may as well take the boxes away, and we are ultimately back to the big ball of mud. Only this time, it's a big ball of mud with a difference. You've rolled it out into 100 Docker containers. There's a famous Stack Overflow question. A guy, and I really wanted to find it and show you it, but it's difficult to Google for, but I remember this. A guy said, I'm having trouble with performance. When an HTTP request comes in, we then call various backend services and microservices, and it ends up in 28,000 calls. It speaks for itself. So, yeah, they're all talking to each other over the network. You've spent 6 months writing this really good deployment system where you can deploy big chunks of them or even all of them at once, right? Because you very often have to. You've ended up with a big ball of mud, Microservices edition. And again, it's a real shame, right? Because you've reached out for microservices that were supposed to help. You've actually ended up in a much worse situation than you started with. What we want are logical service boundaries, okay? So these are logical service boundaries, and they only have IDs going across the wire to each other, ideally. Within them, we may have components. We may have physical components, right? We've already seen that we may be shipping physical components into some kind of system, right? That's kind of our Lego board up there. That system up there might be an iOS app or an Android app. We split things up for other reasons. So within this component here, within this service here, let's say this is something to do with bank accounts. Right? And two of the things it has to do, it has to create bank statements, and it has to lock accounts if fraud is detected. Now, those two things have very different SLAs. Bank statements, they go out once a month. Worst case, they go out a day late. You're not going to go out of business, right? You're not going to really lose money. Fraud, if you detect fraud, you've got to lock that account instantly, right? Because that's leaking cash, right? You know, really bad fraud could even put you out of business. So you create one component for bank statements, you put that on 2 VMs, just for a bit of failover, and that's kind of enough. Fraud, that's where you do your really cool microservice stuff, right? All the stuff you've read about, elastically scaling and using, I don't know, orchestration and Kubernetes and all the rest of it, and elastically scaling and competing consumers on a queue and all that kind of stuff, that's where you go nuts with that stuff, right? You want that stuff to happen instantly. Detect fraud, lock account. Very, very tight SLA. So we split them up for those kind of reasons. Now, you might think, well, isn't this starting to become a kind of mini ball of mud in here? Now, this one's looking a little bit complicated. I'm not going to say that's impossible, right? If you're determined enough, you can create a ball of mud with any architectural approach. But I would say it's much less likely. This is about reducing the likelihood of that happening. It's about because we split things up in here for very different reasons. We split these things up for shipping into systems and for SLA reasons. These are physical, technical things that we split these things up for, not kind of logical things to try and put logical things in different places. That's already done for us with the larger logical service boundaries. Up here, we've got one component, right? So the physical boundary and the logical boundary happen to align just because it makes sense for that service. It doesn't make sense for that service to have any more than one component, right? But so it's by coincidence. The problem with the microservices literature, most of it that you'll read, is that it does conflate the physical with the logical. So the microservice is the logical service, it is the component, it is the thing that you deploy, and it doesn't decouple the physical from the logical. And that's my concern, that too much of the microservices literature distracts us from looking at the logical boundaries and makes us focus solely on the physical boundaries. Right? That's the big thing that concerns me. So I'm coming to the end now. I'm really only scratching the surface here. Right? This is a big topic. If you want to go more deeply into this, follow this URL. So that's go.particular.net/KanDDDinsky-boundaries. What I've done here is I've prepared a series of videos for you. A guy by the name of Udi Dahan, who's our CEO, does a 5-day course, and this is an extract from that, where he goes into this stuff in a lot more detail. So yeah, do go and have a look at that. As I said, if you don't capture that right now, I'll be publishing the slide deck afterwards, so you can grab that, and you can also go and look at Maro's talk, which I referred to. So one last thing I'd like to say is that, like anything you read about in software architecture or literature, this isn't a silver bullet, right? This isn't a golden hammer that will solve all your problems. And it's also not something just for greenfield. Right? Because often people say to me, well, this is fine for a greenfield project, right? But I've got this big ball of mud, what do I do? If you went to Dylan's talk yesterday, he illustrated very nicely why greenfield doesn't exist, right? Greenfield is a myth. So everything I'm talking about here is applicable to legacy software, big balls of mud, and you want to be moving those things slowly towards that, ideally. And this can take years, right? This is not a weeks or months exercise. To transition from a big ball of mud to something better can be years in the making, right? You could be talking 5 years. The kind of greenfield illusion tends to surface a bit in startups as well. Does anyone here work for a startup? Startup-ish kind of thing? There's a few of you. So if you're finding this interesting, and think this might be useful, I've got a little bit of bad news for you. Be very careful about doing this too early in a startup. Because startups don't really know what their businesses are yet. They're trying to find out what their businesses are. So it took Facebook quite a while to realize it's a media company. Right? It puts eyeballs in front of media and sells the eyeballs to advertisers. Right? It's basically a media company, with a slight difference that they don't actually create any media. So it's very lucrative. They've done very well. But when you're in a startup, you've basically got a bunch of ideas, you've got a bunch of toys which are spreading out on the floor, and you're trying to make something work, right? You're trying to find out what your business is. And even if you write something a bit messy, just to prove what you're trying to do, just to see if there's a business there, or you go down this route, when you actually find out what your business is, you're going to have to rewrite it anyway, right? So there's a rewrite coming anyway, in almost all cases. As I said, this is expensive, right? This is an expensive approach which requires a lot of time and investment. So don't be tempted to try this too early in a startup scenario, because it could be a lot of wasted investment. It's often better just to do some kind of proof of concept, just to get something working, to see if you've got a business. So I guess that brings me to the end. I hope you found that useful, enjoyable. I will be around for the rest of the afternoon, so please do grab me and challenge me on this stuff if you've got other questions. Enjoy the rest of the conference. Thank you for having me. Thank you very much.